Hello class, I want to just give you a video of going through this review sheet, and I just want to remind you that tomorrow we will have the equations provided on the test, so I'm just going to write them up here real quick. Okay, so for the first couple equations, they provide us with the sequence formula, so we just need to basically plug in 1, 2, 3, and 4 and to find a to the 1, a to the 2, a to the 3, and a to the 4. So for the first one, for example, I'll plug 1 in, I'll have -7. I'll plug 1 into the other one, that'll be -6, and then I'll plug 1 in again and I'll have -1, and that will make -35. So your answer over here you would submit would be a1 equals -35. When you do a to the second, you plug in 2, so you'll have -6, then -4, and then 0, which would be a to the 2 would equal 0, and a to the 3 and a to the 4 are done the same way, so I'll just save you the time. So that's what your answers would be for number 1. For number 2, we would just plug in 12 in for n. So for number 2, a to the 12 is equal to 5 times 12 minus 7 times 6 times 12 minus 5. And we get for that 3551. For number 3, we need to find the partial sum. So you first need to figure out what type of sequence it is, and it happens to be arithmetic because the d value is equal to 22. The sum equation for the first 10 terms needs the 10th term, so we know the first one is 12. So we know the first one is -21, but we don't know the 10th, so we need to figure that out, and then we'll multiply that by 10 over 2. We find that a to the 10th is equal to, we use the sequence formula for the amount at sequence value 10, and we get 177 for that. And when we plug it into our S10 equation, the sum for the first 10, we end up getting 780. For number 4, we have the story about a man who earns $3,000 each year. Well, the first year, and then each year he gets a $400 raise. So his first year pay is $3,000, and the difference in pay is going to be $400. So we could figure out that what his 15th year would be by using the 15 a sub 15, because it's an arithmetic sequence. So we put in 3,000 plus 15 minus 1 times 400. And we find out that he's earning $8,600 in his 15th year. Next one, it says to find the common difference. So remember, be careful with this. It's -13 minus -10, and that would be -13 plus 10, which would give you -3. So in that case, the sequence is going down by 3 each time. On the next one, it says it's an arithmetic sequence, so that's nice, so we don't have to worry about figuring that out, and it wants to find the 19th term. So a to the 19th equals a to the 1 plus 19 minus 1 times the d value. And the difference value is, we have to subtract 777 from, well, 777 minus 802. And so that's a negative 25. And the 19th term will be 352. Number 7, it asks to find the indicated quantity. So that again is using the sequence equation for an arithmetic. That would just be using the first one, which is 3 plus 8 minus 1 times the difference of 2. So that's going to be 3 plus 7 times 2 is 14. So here we have that value to be 17. On the next question with the sigma notation, it looks a little difficult, but first write out the sequence, or write out the series, because sigma notation means you start at k equals 1, we're going to go up to 46, but we're clearly not going to go to 46. We're going to just write out a few and discover what the sequence or the series is doing. So for instance, when k equals 1, we have 600 minus 3, and then we have 600 minus, we put 2 in, 6, and then we have 600 minus 9, and so on. So we could just say that we're adding up the terms of 597 plus 594 plus 591. So we know the D value here is negative 3, and our A1 value is 597. And then we need to figure out our 46th value by using our sequence equation. So we find our 46th value to be 492, and now we can just plug that into our summation equation. So the sum of 46 terms is equal to our first, which was 597, plus our last, 462, all over or multiplied by 46 divided by 2. Remember what Gauss did. He added the first and the last term and figured out how many pairs of numbers he had. And that's exactly what this formula is all about. So 597 24,357. In the rose garden problem, I would just look at the first row, and they tell you how the sequence diminishes. It goes to 13, then to 11, then to 16 to 13 to 10 to 7 to 4 to 1. And when you add all these up, you find out that those are the 51 bushes. So in this case, you could just figure out quickly that you have 6 rows to answer the question.